On the morning of April the 17th, 1944, Oberfeldwebel Kurt Meyer stood in the maintenance bay of Heavy Panzer Battalion 503, watching his crew attempt to repair their Tiger tank for the third time that week. Meyer was 24 years old. He had commanded this particular Tiger, chassis number 250678, for 9 months. In that time, the tank had spent more hours under repair than in combat. The transmission had failed twice. The final drive had cracked. The overlapping road wheels had frozen solid during the winter, requiring 2 days of work with torches and hammers just to move the tank 10 meters. But on this morning, the problem was simpler and somehow more infuriating. They had run out of fuel. 3rd Panzer Army had requested 30,000 liters of gasoline for the week. They had received 4,000. Without fuel, the most powerful tank ever built was just 57 tons of steel sitting in a barn in eastern Poland, waiting for supplies that would probably never arrive. 2 kilometers away, in a railway depot, Meyer's battalion commander was arguing with a logistics officer about engine parts. The Tiger used a Maybach HL 230 engine, complex, powerful, and prone to failure. Under the extreme weight, it was forced to move. The battalion needed 6 replacement engines. The depot had 2. Those 2 were already promised to another unit. The commander was not accepting this answer well. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Meyer didn't know the strategic situation. He knew his job. He commanded a Tiger tank. The army had trained him for 18 months, taught him to drive, to shoot, to lead a crew, to maintain the most sophisticated armored vehicle Germany had ever produced. But in April 1944, there was no point knowing how to fight if you couldn't move. The Tiger was supposed to change the war. In 1942, when the first Tigers arrived at the Eastern Front, Soviet tank crews had been terrified. The Tiger's 88mm gun could destroy a T-34 from 2,000 meters. Soviet 76mm guns couldn't penetrate the Tiger's frontal armor at any practical range. For a brief period, the Tiger had been invincible. One Tiger could hold off a dozen Soviet tanks. German propaganda had celebrated this. Newsreels had shown Tigers smashing through Soviet defenses, unstoppable, unbeatable. What the newsreels never showed was the logistics. Every Tiger required constant maintenance. The interleaved road wheel system, designed to distribute the tank's immense weight, collected mud and debris. In Russian winter conditions, that mud froze overnight. Come morning, the wheels wouldn't turn. Crews spent hours with blowtorches, heating each wheel individually, hoping the ice would melt before the Soviets attacked. The Tiger's fuel consumption was catastrophic, 450 liters per 100 kilometers on roads. More off-road, a full tank held 540 liters, giving the Tiger a range of about 120 kilometers under ideal conditions. Ideal conditions did not exist on the Eastern Front. Spare parts were a nightmare. The Tiger used custom components that no other German tank used. If a final drive failed, you couldn't borrow one from a Panzer IV. You waited for a shipment from Germany, assuming the trains got through, assuming the factories had produced the part, assuming Allied bombers hadn't destroyed the factory last week. Germany had begun Tiger production in August 1942. The plan had been to build 25 tanks per month initially, ramping up to higher production as factories tooled up and supply chains developed. In reality, production moved slower. October 1942, 12 Tigers. November 15, December 37. The numbers climbed gradually. By April 1944, Henschel was producing about 100 Tigers per month, finally reaching capacity after nearly 2 years of production. 100 tanks per month sounded impressive until you considered what that meant. Heavy Panzer battalions were supposed to have 45 Tigers each. At 100 tanks per month, Germany could barely equip 2 battalions. Every loss in combat took weeks to replace. Every tank destroyed by Allied aircraft, every tank abandoned due to mechanical failure, every tank lost when the crew ran out of fuel and had to blow it up rather than let it be captured, all of those represented weeks of factory production that could never be recovered. Meyer had joined his battalion in July 1943, just after the Battle of Kursk. The battalion had started that battle with 42 operational Tigers. After 2 weeks of fighting, 9 were operational. The rest were destroyed, damaged, or broken down. It had taken 3 months to bring the battalion back to strength. 3 months of waiting for replacement tanks to arrive from Germany, while the Soviets counterattacked and the front line collapsed. The crews had been good. Meyer's commander, killed at Kursk when a Soviet anti-tank round penetrated the Tiger's side armor, had been one of the best tank commanders in the Wehrmacht. Experienced, careful, aggressive when necessary, cautious when prudent. He had destroyed 19 Soviet tanks in 6 months. Then, one lucky shot from a 76mm gun at 400 meters had penetrated the Tiger's thinner side armor and killed him instantly. The tank had been repaired and sent back to Germany. Meyer had never seen it again. What nobody at headquarters seemed to understand was that Germany was losing the war of arithmetic. The Tiger was technically superior to anything the Allies fielded in 1943. Thicker armor, more powerful gun, better optics. In a one-on-one engagement, the Tiger won almost every time. But wars weren't fought one-on-one. The Soviets didn't send one T-34 to fight one Tiger. They sent 10, 20, 50. They could afford to lose 45 tanks destroying one Tiger because they had factories producing hundreds of tanks every month. The Americans were worse. Meyer had heard stories from veterans who had fought in France. They described American tank formations that seemed endless. Destroy 5 Sherman tanks, and 10 more appeared. Destroy those, and 15 more came over the hill. The Americans never seemed to run out of tanks, never seemed to run out of ammunition, never seemed to run out of anything. In the maintenance bay, Meyer's driver finally got the Tiger's engine running. Black smoke poured from the exhaust. The Maybach engine rumbled, settled into an uneven idle, and died again. The driver swore, climbed out, began checking fuel lines. Meyer watched without offering suggestions. He had learned months ago that sometimes the best thing a commander could do was let his crew work. Germany had built approximately 1,350 Tigers by the time production ended in August 1944. 1,350 tanks over 2 years. Every single one had been hand-assembled by skilled workers using components manufactured in dozens of different factories across Germany and occupied Europe. The Tiger's turret came from Krupp, the hull from a different contractor, the transmission from another, the engine from Maybach, the gun from yet another factory. All of these components had to be transported by rail to Henschel's factory in Kassel, where final assembly occurred. Allied bombing had complicated everything. Factories that should have been producing Tiger components were being rebuilt after air raids. Rail lines that should have been transporting parts were being repaired after bombing runs. Workers who should have been assembling Tigers were dead or injured or working to clear rubble from previous attacks. Every delay rippled through the production system. A bombed bearing factory meant transmissions couldn't be completed. Incomplete transmissions meant final assembly had to wait. Waiting assembly meant combat units didn't get replacement tanks. The cost in labor was staggering. Each Tiger required 300,000 man-hours to build, 300,000 hours of skilled labor, much of it performed by workers who could have been building other things. A Panzer IV required 90,000 man-hours. A Stu-G3 assault gun required even less. For the labor cost of one Tiger, Germany could build 3 Panzer IVs or 4 Stu-G3s. From a purely mathematical standpoint, this was insane. But the Tiger wasn't built for mathematics. It was built for psychological impact. German planners in 1941 and 42 had believed that a small number of incredibly powerful tanks could terrorize enemy forces, break through defensive lines, and achieve strategic victories that cheaper, more numerous tanks could not. For a brief period in 1942 and early 43, this had worked. Tiger battalions had punched holes in Soviet defenses. British and American tank crews in North Africa had learned to avoid Tigers when possible, engaging them only with overwhelming numbers or from ambush positions. By 1944, the psychological advantage had evaporated. Allied tank crews were no longer terrified of Tigers. They were cautious, respectful of the Tiger's capabilities, but they had learned that Tigers could be killed, flank shots worked, close-range ambushes worked, overwhelming numbers worked, and, most effective of all, simply waiting worked. Tigers broke down so frequently that Allied tankers had learned to let mechanical failures do the work. Why risk your crew trying to destroy a Tiger when there was a decent chance it would throw a track or burn out its transmission within a few kilometers? The final drive problem was particularly insidious. The Tiger's final drives, the mechanism that transferred power from the transmission to the drive sprockets, were not designed to handle 57 tons. The engineers had known this. They had requested time to redesign the system. Hitler had demanded that Tigers enter production immediately, so the inadequate final drives had been used. In combat conditions, with the tank moving over rough terrain, accelerating, braking, turning sharply, the final drives often failed after a few hundred kilometers. Once failed, the tank was immobile. It had to be towed back to a maintenance depot, assuming a recovery vehicle was available, assuming the tactical situation allowed for recovery. Many Tigers were simply abandoned. When final drives failed deep in enemy territory or during retreats, crews had no choice but to destroy their tanks and escape on foot. The Wehrmacht had lost hundreds of Tigers, not to enemy fire, but to mechanical failures that occurred at inopportune moments. Every abandoned Tiger represented 300,000 man-hours of labor, tens of thousands of Reichsmarks in materials and manufacturing costs, and months of production time, all wasted because a 50 Reichsmark bearing had given out. Meyer's driver got the engine running again. This time it held. The rough idle smoothed out, the black smoke cleared. Meyer climbed aboard, dropped into the commander's cupola, and gave the order to move forward. The Tiger lurched, tracks clanking, and rolled 10 meters before stopping. The driver reported that the transmission was slipping. They would need to replace the clutch plates. That would take 6 hours, assuming they had the parts. They probably didn't have the parts. Across occupied Europe, similar scenes were occurring in hundreds of maintenance depots. Tiger crews struggled to keep their tanks operational. Spare parts didn't arrive. Fuel allocations were cut. Experienced crew members were killed and replaced with poorly trained teenagers who barely knew how to load the main gun. The elite heavy tank battalions that were supposed to be Germany's armored fist were withering away, not destroyed in glorious combat, but consumed by the grinding reality of industrial warfare. What Meyer didn't know, couldn't know, was that the war had already been decided, not by tactics or strategy or the fighting spirit of German soldiers, but by production numbers. While Germany struggled to build 100 Tigers per month, American factories were producing Sherman tanks at rates that would have seemed impossible to German planners. The numbers were so lopsided that even if every Tiger performed perfectly, even if German crews never made mistakes, even if mechanical failures never occurred, Germany still couldn't win. There simply weren't enough Tigers. The mathematics were brutal. Germany's total Tiger production through August 1944 would reach 1,347 tanks. That's all models, all variants, across 2 years of maximum effort. The United States had begun Sherman production in February 1942. By mid-1942, American factories were producing 2,000 Shermans per month. 2,000 tanks monthly from a production system that Germany couldn't match, couldn't even comprehend. This wasn't about better tanks. This was about more tanks. An endless, unstoppable flood of tanks that arrived faster than they could be destroyed. German intelligence officers had tried to explain this to leadership. They had shown production estimates, calculated ratios, demonstrated that Germany was being buried under American industrial capacity. Leadership had dismissed the reports. German tanks were better, therefore Germany would win. The logic was comforting and completely wrong. Meyer didn't think about production numbers. He thought about getting his tank running so his crew could eat dinner in the mess hall instead of spending another night in the maintenance bay. He thought about the fuel situation, which wasn't getting better. He thought about the rumors that 3rd Panzer Army was going to be transferred west to France because Allied invasion was expected soon. He thought about a lot of things, but he didn't think about American factories in Detroit and Michigan, working 3 shifts per day, producing tanks at rates that would have required every factory in Germany working simultaneously to match. On March 15th, 1943, John Novak stood on the floor of the Chrysler Tank Arsenal in Warren, Michigan, watching a Sherman tank roll off the production line every 48 minutes. Novak was 32 years old. Before the war, he had assembled automobiles at a Chrysler plant in Detroit. Now, he assembled tanks at a factory that hadn't existed 3 years earlier. The work was different in scale, but similar in principle. Move the product, standardize the parts, keep the line running. Every delay cost time. Time cost production. Production won wars. The Chrysler Tank Arsenal was a purpose-built facility designed specifically to mass-produce tanks using automotive manufacturing techniques. The building covered over 1 million square feet. When construction began in September 1940, the site had been farmland. Cows had grazed where Sherman tanks now rolled off assembly lines. The factory was completed in 9 months, an engineering feat that German planners would have considered impossible. By April 1941, the first tanks were being assembled, even as construction workers finished portions of the building. The man who made this possible was K.T. Keller, president of Chrysler Corporation. Keller had been approached by the War Department in mid-1940 with a request that Chrysler consider producing tanks. The United States Army had fewer than 400 modern tanks in 1940. France had fallen. Britain was under siege. President Roosevelt had called for 50,000 combat aircraft and matching numbers of tanks to confront what he termed the approaching storm of global conflict. American industry would have to transform overnight from producing civilian goods to producing weapons of war. Keller had agreed immediately. Not because it was patriotic, though it was. Not because it was profitable, though it would be. Keller agreed because he understood that modern warfare was industrial warfare. Wars would be won by whoever could produce the most weapons fastest. Germany had a head start, but Germany didn't have Detroit. Germany didn't have the automotive industry that had revolutionized manufacturing. Germany couldn't mass-produce tanks the way America mass-produced cars. Keller intended to prove that the tank arsenal was designed around principles Henry Ford had established decades earlier at Highland Park and River Rouge. Move the work to the workers. Standardize components so they're interchangeable. Break complex tasks into simple, repetitive operations. Feed sub-assemblies to the main line at precise intervals. Eliminate wasted motion, wasted time, wasted materials. These principles had made automobiles affordable to average Americans. They would make tanks available to the Army in quantities no enemy could match. Novak Station was a turret installation. The Shermans turret, weighing several tons, arrived on an overhead conveyor from the turret assembly area. Novak and his team guided it into position over the hull, which arrived on the main assembly line from the hull fabrication section. The turret lowered onto the turret ring, a precisely machined circular interface that allowed the turret to rotate. 4 men secured the turret to the hull using bolts that had to be torqued to exact specifications. The operation took 12 minutes. 12 minutes from start to finish. Then the partially completed tank moved down the line and another hull arrived for the next turret. The factory operated 3 shifts, 24 hours per day, 7 days per week. Workers like Novak worked 8-hour shifts with 30-minute lunch breaks. The factory never stopped. When Novak's shift ended, another crew took over his station and continued the work. Tanks that had been empty hulls at the start of his shift were fully assembled and tested by the time he returned the next day. The factory produced an average of 1,500 Sherman tanks per month by mid-1943. That's 50 tanks per day. 1 tank every 29 minutes, around the clock. Compare that to Tiger production. Henschel's factory in Kassel produced about 100 Tigers per month at peak capacity in 1944, 100 tanks monthly from Germany's most advanced tank factory. Chrysler Tank Arsenal alone was producing 15 times that number, and Chrysler wasn't the only Sherman producer. Fisher Tank Arsenal in Grand Blanc, Michigan, produced similar numbers. Prest Steel Car Company in Pennsylvania produced thousands more. Pacific Car and Foundry in Washington State, Lima Locomotive Works in Ohio, American Locomotive Company in Schenectady, New York. 11 different factories across the United States, all producing Sherman tanks using standardized components that could be shipped between plants and assembled anywhere. The production numbers were staggering. In 1942, American factories built approximately 19,000 Sherman tanks. In 1943, production increased to 21,000. Peak monthly production reached 2,000 tanks in mid-1942 and remained at that level or higher through 1944. By comparison, Germany produced approximately 6,000 total tanks of all types in 1943, including Panzer IIIs, Panzer IVs, Panthers, and Tigers. The United States produced more Sherman tanks in 2 months than Germany produced total tanks in a year. This wasn't accidental. This was the result of deliberate industrial planning that began in 1940, before the United States entered the war. Army ordnance officers had studied German tank production methods and concluded they were inadequate for modern warfare. German tanks were over-engineered, hand-assembled by skilled craftsmen built in small numbers at high cost. The German approach produced excellent individual tanks but couldn't produce enough tanks to win a war of attrition. The American approach was different. Design a tank that was good enough rather than perfect. Make it reliable rather than sophisticated. Use components that were easy to manufacture and assemble. Prioritize quantity over quality, knowing that numerical superiority would overcome technical inferiority. The Sherman wasn't the best tank in the world in 1943. It was the most producible tank in the world. That distinction mattered more. The Sherman used a welded hull that could be fabricated in sections and assembled on the line. The Tiger used a complex hull with interlocking armor plates that required precision fitting. The Sherman's suspension used vertical volute springs, a simple, robust system that had been proven on American light tanks in the 1930s. The Tiger used an interleaved road wheel system that was theoretically superior, but practically a maintenance nightmare. The Sherman's transmission was adapted from a commercial vehicle design. The Tiger's transmission was custom-built and chronically unreliable under the extreme weight it had to move. Every design choice in the Sherman prioritized manufacturability. The 75mm gun was less powerful than the Tiger's 88mm gun, but it was simpler to produce and adequate for most combat situations. The armor was thinner than the Tiger's, but it was sufficient against most German anti-tank weapons in 1942 and early 1943. The engine was less powerful than what some officers wanted, but it was reliable and based on proven automotive technology. The Sherman was a compromise in every dimension, and those compromises allowed it to be produced at rates that made technical superiority irrelevant. Novak didn't think about this. He thought about torque specifications and bolt sequences and maintaining the rhythm that kept the line moving. The foreman had made it clear. Production delays were unacceptable. Every tank that left the factory went to a combat unit that needed it. Men were dying in North Africa and Italy and the Pacific because they didn't have enough tanks. The factory's job was to produce tanks faster than combat units could lose them. Everything else was secondary. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The workforce was different from what most people imagined. Novak worked alongside women, something that would have been unusual in a car factory before the war. By 1943, women comprised about 25% of the tank arsenal workforce. They worked as welders, riveters, machine operators, quality control inspectors. Some of the best welders in the factory were women who had never touched a welding torch before 1942. They learned quickly because the factory needed them and because the training programs were effective. The factory had also hired thousands of African-American workers from the South. The war had created labor shortages that forced northern factories to hire workers they would have rejected in peacetime. The tank arsenal employed integrated work crews, black and white workers, on the same assembly lines. This wasn't progressive social policy. This was pragmatic necessity. The factory needed 40,000 workers to maintain 3-shift production. Finding 40,000 white male workers was impossible. The factory hired whoever could do the work. Training took weeks. New workers attended classes where they learned basic welding, riveting, blueprint reading, quality control procedures. Then they worked alongside experienced workers for several days before taking their own stations. The best workers moved up quickly. Novak had started as a hull welder. After 6 months, he was a team leader, supervising 5 other workers. After a year, he was training new hires. The factory promoted based on competence, because there was no time for anything else. The supply chain was equally impressive. A Sherman tank contained approximately 50,000 individual parts. Those parts came from hundreds of subcontractors across the United States. Steel mills in Pennsylvania and Ohio provided armor plate. Rubber companies in Akron produced track pads. Gun manufacturers in New England made the 75mm cannon. Electronics companies made radios. All of these components arrived at the tank arsenal on precise schedules, delivered by truck and rail, unloaded at specific receiving docks, moved to staging areas, and fed to assembly lines exactly when needed. The coordination required was immense. A delay at a steel mill in Pittsburgh could shut down tank production in Michigan. A late shipment of electrical components could create bottlenecks. The logistics officers who managed this system worked with the same precision that factory workers used on the assembly line. Every component tracked, every delivery scheduled, every potential disruption anticipated and mitigated. The system occasionally broke down, but it broke down rarely enough that production targets were consistently met. Quality control was rigorous. Every Sherman underwent testing before leaving the factory. Inspectors checked welds, tested electrical systems, verified that turrets rotated smoothly, confirmed that guns elevated and depressed properly. Test drivers took each tank on a short course outside the factory, accelerating, braking, turning, checking for mechanical problems. Tanks that failed inspection went back to the line for repairs. Tanks that passed inspection were driven onto railroad cars for shipment to ports or training bases. By late 1943, the factory was producing tanks so quickly that storage became an issue. Completed Shermans sat in vast lots outside the factory, row after row of olive-drab armor, waiting for railroad cars to ship them. At any given time, hundreds of finished tanks were in storage. This would have been unthinkable in Germany, where every completed Tiger was rushed immediately to combat units. American production was so excessive that tanks sat in storage lots because there weren't enough ships to transport them overseas fast enough. The cost per tank dropped as production increased. Early Shermans cost approximately $65,000 to produce in 1942 dollars. By 1943, improvements in manufacturing efficiency had reduced costs to approximately $57,000 per tank. By 1944, costs had dropped further. Every efficiency gain translated to more tanks for the same budget. Every manufacturing improvement meant shorter production times and higher output. Compare this to the Tiger. Each Tiger cost 250,000 Reichsmarks in 1943. Converting historical exchange rates is complicated, but rough estimates suggest this was equivalent to approximately $100,000. A Tiger cost nearly twice as much as a Sherman. Germany spent the equivalent of 15 Shermans' worth of resources to build one Tiger. From a resource allocation standpoint, this was catastrophic. Germany was trading quantity for quality at a ratio that guaranteed defeat. The Tiger was technically superior in most measurable ways: thicker armor, more powerful gun, better optics. In a one-on-one engagement, the Tiger usually won. But combat wasn't one-on-one. American doctrine called for combined arms warfare. Shermans operated with tank destroyers, artillery, infantry, and air support. When American forces encountered Tigers, they didn't send one Sherman to fight it. They sent 5 Shermans, 2 tank destroyers, and called in artillery or airstrikes. The Tiger might destroy 2 or 3 Shermans before being knocked out, but the Americans could afford those losses. They had thousands of replacement tanks waiting in depots. This was the fundamental asymmetry the German planners failed to grasp. Germany built tanks for tactical superiority. America built tanks for strategic victory. The German approach worked in individual battles. The American approach worked in campaigns. By 1944, the cumulative effect of American production was overwhelming German forces, not through superior tactics or better soldiers, but through simple arithmetic. There were always more American tanks, always more artillery shells, always more aircraft, always more of everything. Novak watched another Sherman roll past his station, turret installed, main gun mounted, machine guns in place. The tank moved down the line toward final assembly. In 3 hours, it would be tested and loaded onto a railroad car. In 3 weeks, it would be in England preparing for the invasion of France. In 4 weeks, it might be in combat. The tank Novak had just worked on would join thousands of others massing for the largest amphibious invasion in history. German intelligence knew the invasion was coming. They knew approximately when and approximately where. What they didn't know, couldn't know, was that American and British forces would land with such overwhelming numbers that German defenses would be irrelevant. The Allies would bring thousands of tanks ashore in the first week. Thousands more would follow in subsequent weeks. German panzer divisions would fight desperately, inflicting casualties, destroying hundreds of Allied tanks. It wouldn't matter. The Allies would replace losses faster than Germany could inflict them. By June 1944, when Allied forces landed in Normandy, the United States had produced approximately 38,000 Sherman tanks. 38,000 tanks in approximately 2 years of production. Germany had produced approximately 1,000 Tigers in the same period. The numerical advantage was 38-1. Even accounting for German production of other tank types, the advantage was still more than 5-1. The Allies could afford to lose 5 tanks for every German tank destroyed and still win through sheer numerical superiority. This was mass production as a weapon of war, not sophisticated engineering or tactical brilliance or superior training. Though all of those mattered, the decisive weapon was industrial capacity, the ability to produce weapons faster than the enemy could destroy them, the ability to replace losses immediately, the ability to field forces so large that the enemy couldn't engage them all simultaneously. This was how America fought wars in 1944, not through finesse, but through overwhelming material advantage. The German military tradition emphasized the decisive battle, the brilliant maneuver, the knockout blow. German officers studied Clausewitz and admired Napoleon's campaigns. They believed that superior tactics and operational art could overcome material disadvantages. This had worked. In the early war, German forces had defeated Poland, France, and much of the Soviet Union through superior tactics and aggressive maneuver warfare. By 1944, that approach no longer worked. The Allies had learned German tactics and developed counters. More importantly, Allied material superiority had reached levels where tactics couldn't compensate. A German panzer commander in Normandy might execute a tactically perfect ambush, destroy a dozen Sherman tanks, and withdraw successfully. Operationally, this meant nothing. The destroyed Shermans would be replaced within days. The panzer unit, having expended ammunition and fuel, would have to wait weeks for resupply. Meanwhile, more Allied tanks would arrive, more artillery would move forward, more infantry would advance. The Germans could win every tactical engagement and still lose the campaign because they couldn't sustain operations against opponents who could replace losses instantly. This realization occurred gradually among German officers. Veterans who had fought on the Eastern Front understood it first. They had seen Soviet tank production overwhelm German forces through sheer numbers. Officers transferred from the East to the West brought this knowledge with them. They tried to explain to colleagues that the Allies couldn't be defeated militarily, that Germany was fighting industrial capacity, not armies. Many officers refused to believe this. The German army had never lost because of production deficiencies. German soldiers were better trained, better led, more experienced. Quality would triumph over quantity. It didn't. In Normandy, in Italy, in the East, German forces fought brilliantly and lost steadily. Every tactical victory was strategically meaningless. Every destroyed Allied tank was replaced. Every casualty inflicted was matched by fresh troops. The Wehrmacht was fighting the industrial output of the United States, Britain, and the Soviet Union combined. Germany's total industrial production was approximately 1/5 of Allied production. This gap couldn't be closed by fighting harder or training better or building superior weapons. The mathematics were inexorable. Novak's shift ended at 4 in the afternoon. He clocked out, walked through the factory gates, joined the stream of workers heading to the parking lots and bus stops. Behind him, the next shift was already taking stations on the assembly line. The factory would continue producing tanks through the night, through tomorrow, through next week and next month. Production would continue until the war ended or until there were so many tanks that further production was unnecessary. Given current production rates and loss rates, the latter seemed more likely. On June 7, 1944, Oberfeldwebel Kurt Meyer watched American Sherman tanks roll off landing craft onto the beaches of Normandy and realized that Germany had already lost the war. Meyer's Tiger Battalion had been rushed to Normandy from Poland after the invasion began. They had arrived with 18 operational Tigers. Within a week, they were down to 9. Not because of combat losses primarily, though there had been some. Mechanical failures, fuel shortages, lack of spare parts. The same problems that had plagued them in Poland followed them to France. Meyer's own Tiger had thrown a track on the drive from the railhead to their assembly area. It had taken 6 hours to repair because the battalion's maintenance crews were exhausted and short on tools. By the time his tank was operational again, the tactical situation had deteriorated. Allied air superiority meant Tigers couldn't move during daylight without risking attack from fighter bombers. The battalion moved at night, hid during the day, and tried to find defensive positions where their superior firepower and armor could compensate for their lack of numbers. From his position in a hedgerow overlooking a road junction, Meyer counted Sherman tanks. He stopped counting at 30. They kept coming, column after column, moving inland from the beaches, spreading across the Norman countryside. American logistics were visible and overwhelming. Fuel trucks followed the tanks. Ammunition trucks followed the fuel trucks. Recovery vehicles towed damaged Shermans back toward the beaches, while fresh Shermans moved forward. The Americans had created a supply system that simply worked, moving thousands of tons of materiel from ships to combat units with mechanical efficiency. Meyer's battalion commander had briefed the crews on what to expect. American tank tactics were predictable. Shermans would advance in groups trying to flank German positions. Individual Shermans were vulnerable. The Tiger's 88mm gun could destroy a Sherman from 2,000 meters. Sherman's 75mm guns couldn't penetrate Tiger frontal armor at any practical combat range. In theory, one Tiger could hold off multiple Shermans. Theory collapsed when confronted by reality. The Americans didn't attack with 3 or 4 Shermans. They attacked with 20. They didn't retreat when they took losses. They kept coming. Destroy 5 Shermans, and 10 more appeared. The Americans fought like they had unlimited resources, because they effectively did. Production was so excessive that combat losses were statistical noise. Tank crews lost in Normandy were replaced within days. Tanks destroyed on a Tuesday were replaced by Thursday. The American military machine absorbed losses that would have crippled German formations and continued operating without pause. The first engagement occurred on June 10th. Meyer's platoon of 3 Tigers had taken defensive positions overlooking an approach route. American infantry had probed their positions at dawn, pulled back after encountering resistance. Around noon, American artillery began hammering the hedgerows. The barrage lasted 40 minutes, longer than German artillery would have sustained because German artillery was rationing ammunition. American artillery apparently had no such concerns. Shells fell in steady patterns, methodical and overwhelming. When the barrage lifted, Sherman tanks advanced. Meyer counted 12 in the first wave. His gunner engaged at 1,500 meters, destroying the lead Sherman with the first shot. The other Shermans spread out, moving behind hedgerows, using terrain for cover. 2 more Shermans died in the next 2 minutes. The Americans didn't retreat. They continued advancing, suppressing Meyer's position with high explosive rounds, while other Shermans maneuvered for flank shots. Meyer's Tiger killed 7 Shermans in 11 minutes. The Americans withdrew after losing 8 tanks, leaving 3 burning and 5 damaged. German doctrine would have called this a victory. Meyer knew it wasn't. The Americans would return tomorrow with more tanks. His Tiger had expended 30% of its armor-piercing ammunition. Resupply would take days if it came at all. The battalion's ammunition depot had been hit by Allied aircraft 2 days earlier. Remaining stocks were being rationed. More concerning was fuel. The Tiger had burned through 80 liters, maneuvering during the engagement. The battalion had received its last fuel delivery 5 days ago. Tanks were being kept stationary, except during combat to conserve fuel. This defensive posture made tactical sense, but surrendered the initiative completely to the Americans, who moved freely because their supply lines functioned Over the next 2 weeks, Meyer's battalion fought a series of defensive engagements. They destroyed dozens of American tanks. The Americans kept attacking. Every defensive position eventually became untenable because American artillery and air power made them uninhabitable. The battalion would destroy a company of Shermans, then withdraw during the night to avoid airstrikes, then establish new positions farther from the beaches. This pattern repeated continuously. Fight, withdraw, reposition. The Germans were trading space for time, hoping that inflicting enough casualties would slow the American advance. It didn't slow anything. Allied forces expanded their beachhead methodically. By late June, they controlled most of the Cotentin Peninsula. German forces had fought desperately, inflicted thousands of casualties, destroyed hundreds of tanks and vehicles. None of it mattered strategically. The Allies replaced losses faster than Germany inflicted them. Meanwhile, German forces couldn't replace their losses at all. Every dead soldier, every destroyed tank, every expended artillery shell represented an irreplaceable loss. Meyer's Tiger was knocked out on June 24th, not by enemy fire. The final drive failed while the tank was repositioning during the night. The tank rolled forward 30 meters, made a grinding noise, and stopped. The driver tried to engage the transmission. Nothing happened. They were immobile in an open field, half a kilometer from their designated position. The crew spent 2 hours trying to repair the final drive, using tools and spare parts they didn't have. At dawn, Meyer made the decision. They couldn't repair the tank. They couldn't call for recovery because the battalion's recovery vehicles were supporting other disabled tanks. Allied aircraft would spot them as soon as it was light enough to fly. Meyer ordered his crew to remove the breech block from the main gun, destroy the radio, and prepare demolition charges. At 6:15 in the morning, they detonated explosives inside the turret and engine compartment. The Tiger burned for 3 hours. Meyer and his crew walked 12 kilometers to rejoin the battalion. Of the 18 Tigers the battalion had brought to Normandy 3 weeks earlier, 5 were still operational. The others had been destroyed in combat, knocked out by mechanical failures, or abandoned when they couldn't be recovered. The Tiger that Meyer had commanded for 9 months, that he had maintained through Russian winter and Polish mud, that had survived Kursk and dozens of smaller engagements, died in a Norman field because a bearing had failed at an inopportune moment. 300,000 man-hours of German labor gone. Months of factory production wasted. All the training, all the experience, all the maintenance work irrelevant because one component had worn out and couldn't be replaced. This was happening across Normandy. German panzer divisions were disintegrating, not primarily through combat, but through mechanical attrition and supply failure. Panther tanks, technically superior to Shermans, broke down at rates that made them strategically useless. Tigers fought brilliantly in individual engagements and lost campaigns because there weren't enough of them and they couldn't be sustained logistically. The German armored force that was supposed to throw the Allies back into the sea was being ground down by the cumulative effects of Allied material superiority. American forces, meanwhile, were growing stronger. More divisions landed every week. More tanks arrived every day. Supply depots expanded across the beachhead. The logistics system that had seemed impossible to German observers was functioning exactly as designed. Ships unloaded continuously at artificial harbors. Trucks moved supplies inland on roads that engineers maintained constantly. Tank recovery vehicles brought damaged Shermans back to field maintenance depots where crews repaired them and returned them to combat within days. The disparity in recovery capabilities alone was decisive. When a Sherman threw a track or had engine trouble, recovery vehicles towed it to a maintenance area where mechanics fixed it. Most mechanical failures were repaired and returned to service within 48 hours. When a Tiger had mechanical problems, it often had to be abandoned because recovery vehicles weren't available or the tactical situation didn't permit recovery operations. The Americans recovered approximately 80% of disabled tanks. The Germans recovered perhaps 40%. This meant American tank strength remained relatively constant despite losses, while German tank strength declined continuously. By August 1944, the Normandy campaign had demonstrated conclusively that German armored forces couldn't stop Allied advances through tactical skill or technical superiority. The mathematics were inexorable. Germany had lost approximately 1,500 tanks and assault guns in Normandy. The Allies had lost approximately 4,000 tanks in the same period. Germany couldn't replace their losses. The Allies replaced theirs within weeks and had more tanks in France in September than they'd had in June. The Tiger program's failure was particularly stark. Germany had invested enormous resources developing and producing a technically superior heavy tank. In combat, Tigers had achieved favorable kill ratios, destroying multiple enemy tanks for each Tiger lost. Strategically, this meant nothing. Total Tiger production through August 1944 was 1,347 tanks. American Sherman production in the same period was approximately 45,000 tanks. Even if Tigers achieved 5-to-1 kill ratios consistently, which they didn't, the arithmetic favored the Americans overwhelmingly. German planners had made a fundamental error. They had assumed that technical quality could substitute for quantity. They had designed tanks that were superior in individual engagements and ignored the reality that modern war was fought by industrial systems, not individual weapons. The Tiger was a masterpiece of engineering that lost to a mediocre tank produced in overwhelming numbers. This wasn't because American engineers were more clever. It was because American industrialists understood that wars are won by production capacity. The Sherman wasn't designed to be the best tank. It was designed to be good enough, reliable enough, and producible in quantities that would overwhelm any enemy. Every design compromise in the Sherman served this goal. The welded hull was easier to produce than the Tiger's complex armor assembly. The suspension was simpler and more reliable. The engine was less powerful, but far more dependable. The gun was adequate rather than excellent. These compromises allowed American factories to produce Shermans at rates that made German production look artisanal. The difference wasn't just factory capacity, it was industrial philosophy. American manufacturing had evolved through decades of automotive production. Henry Ford's assembly line had revolutionized manufacturing in the 1910s and 20s. By the 1940s, American industry had perfected mass production techniques, standardization, interchangeable parts, moving assembly lines, statistical quality control. These weren't new concepts. They were established practice. Applying them to tank production was straightforward once the decision was made to prioritize quantity. German industry hadn't evolved the same way. German manufacturing emphasized craftsmanship and precision. German tanks were hand-assembled by skilled workers who fitted components individually. This produced excellent individual tanks, but couldn't produce them quickly or cheaply. The German approach worked for luxury automobiles and precision instruments. It failed for weapons that needed to be produced by the thousands. The cultural difference manifested in production methods. American factories used unskilled and semi-skilled workers who performed simple, repetitive tasks. Training took weeks. Workers didn't need to understand the entire tank, just their specific operation. German factories used skilled craftsmen who understood complex systems and could troubleshoot problems. Training took months or years. This produced better individual workers, but limited production scaling. When wartime demand required rapid production expansion, the American system scaled effortlessly. Factories hired thousands of new workers, trained them quickly, and put them on assembly lines. Production increased proportionally to workforce size. The German system couldn't scale the same way. Skilled workers couldn't be created quickly. Attempts to use unskilled labor in German factories resulted in quality problems that slowed production further. By mid-1944, the cumulative effect of these differences was visible on every battlefield. Allied forces had material superiority so overwhelming that tactical skill couldn't compensate. German commanders executed brilliant maneuvers that achieved nothing because the Allies simply absorbed losses and continued operations. The Wehrmacht was fighting 20th century industrial warfare with 19th century production methods. The outcome was never in doubt once American industry reached full production capacity. Meyer, having lost his Tiger, was assigned to a Panzer IV as a gunner. The Panzer IV was Germany's workhorse medium tank, less powerful than the Tiger, less well-armored, but more reliable and more numerous. The Wehrmacht had produced approximately 9,000 Panzer IVs by mid-1944. This was Germany's most successful tank numerically. It was still outnumbered 5-1 by Shermans in the European theatre. Meyer's new tank had a tired engine, worn tracks, and a crew that had lost 3 tanks in 6 weeks. They fought through Normandy's hedgerows, withdrew across France during August, and ended up in Germany by September, defending against Allied advances that couldn't be stopped. The industrial disparity that doomed Germany wasn't limited to tanks. It extended to every category of military equipment. American factories produced twice as many aircraft, 3 times as many trucks, 5 times as many artillery pieces. The United States built Liberty ships faster than German U-boats could sink them. American steel production exceeded German, Italian, and Japanese production combined. The Allies had economic superiority so complete that military outcome was determined before most battles were fought. German soldiers fought with incredible determination. German officers demonstrated tactical skill that Allied commanders often couldn't match. None of it mattered strategically. Germany was fighting opponents who could lose battles continuously and win campaigns through material attrition. This was industrial warfare at its most fundamental level. Production capacity determined victory. Everything else was detail. By late 1944, even German propaganda couldn't hide reality. News from the fronts was universally bad. Soviet forces were advancing in the east. Allied forces were advancing in the west and south. German cities were being destroyed by strategic bombing. The wonder weapons that propaganda had promised, jet aircraft, rocket weapons, super heavy tanks, were too few and too late. Germany was being crushed between Allied forces that had unlimited resources and German forces that had exhausted theirs. The Tiger program exemplified German strategic failure. Enormous resources invested in a weapon that was tactically superior and strategically irrelevant. If Germany had invested those same resources, producing more Panzer IVs, would it have changed the outcome? Probably not. American production would still have been 5 times greater. Soviet production would still have been 3 times greater. Germany could optimize production and still lose because the fundamental economic disparity was insurmountable. The only path to German victory would have been avoiding the war entirely or winning it before Allied production reached full capacity. By 1944, that window had closed. Germany was fighting a war of attrition against enemies with 5 times its economic capacity. The Wehrmacht could win every tactical engagement and still lose because tactics don't overcome economics in industrial warfare. Meyer survived the war. His Panzer IV was knocked out in January 1945 by an American tank destroyer. He and his crew surrendered. Meyer spent 2 years in a prisoner of war camp, returned to Germany in 1947, found a country destroyed and an economy devastated. He worked in construction, rebuilding cities that Allied bombing had flattened. He rarely talked about the war. When asked what he had learned, he usually said that Germany had fought enemies who simply had more of everything. More tanks, more planes, more trucks, more ammunition, more fuel, more soldiers, more of everything. Quality couldn't overcome quantity at the scale the Allies operated. American production was the decisive weapon of World War II. Not atomic bombs or radar or code breaking, though all of those mattered. The weapon that won the war was factories in Detroit and Michigan and Pennsylvania producing tanks, trucks, aircraft and ships faster than enemies could destroy them, mass production as a strategic weapon, industrial capacity as military force. This was how America fought and won its wars. The Sherman tank wasn't the best tank of World War II. It was the most important tank because it was producible in quantities that made other considerations irrelevant. Germany built 1,347 Tigers, engineering marvels that achieved impressive combat records, and lost the war anyway. America built 49,000 Shermans, adequate tanks that won through sheer numbers. This wasn't elegant or sophisticated. It was effective. The lesson was clear, but often misunderstood. Wars between industrial nations are won by production capacity, not tactical brilliance. The side that can produce more weapons, replace more losses, and sustain operations longer will win regardless of weapon quality or tactical skill. Germany learned this lesson too late. The Wehrmacht fought brilliantly and lost because they couldn't match Allied production. Technical superiority meant nothing against enemies who could field 5 tanks for every German tank, 10 artillery pieces for every German gun, 20 trucks for every German truck. This fundamental asymmetry determined World War II's outcome more than any battle or campaign. The Allies won because American factories produced weapons faster than Axis forces could destroy them. Everything else, tactics, strategy, leadership, morale, technology, mattered at the margins. The core reality was industrial capacity. The United States had it. Germany didn't. That gap couldn't be bridged by fighting harder or designing better weapons. The mathematics were inexorable from the moment America entered the war and its factories converted to military production. By war's end, the numbers told the story completely. Germany had produced approximately 25,000 tanks of all types during World War II. The United States produced approximately 89,000 tanks in the same period, including Shermans, light tanks, and tank destroyers. Soviet production exceeded 100,000 tanks. The Axis powers faced Allied production that was 8 times greater. No amount of tactical skill or weapon superiority could overcome that disparity. The Tiger tank was Germany's attempt to offset numerical inferiority with qualitative superiority. It failed, not because the Tiger was a bad tank, it was an excellent tank, but because excellence doesn't scale. You can build excellent weapons in small numbers or adequate weapons in large numbers. You can't build excellent weapons in large numbers without industrial capacity that Germany didn't possess. The Americans understood this. They built adequate weapons in overwhelming numbers and won decisively. This was the real story of the Tiger versus the Sherman. Not which tank was better in individual combat, but which production strategy was sustainable in total war. Germany bet on quality, America bet on quantity. The war proved that quantity has a quality all its own when the numbers reach certain levels. The Americans reached those levels. Germany never could. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.